turn over. Now we're going to get to sharks. Some of you will like this and some of you won't.
I said to you that the Catherine great white was a huge great white.
We're going to talk about her.
Okay,
We've got it. I've got a picture. Thank you. And then you can help add stuff to it. On page 119, we have shark migrations. And the two sharks that the book listed were the bull shark and the sandbar shark, and we will mention the great white shark too, because that has come up locally in the last couple of years, so we're going to talk about that quickly. Notice that the bull shark, and I found this interesting, there were a lot, that's a bull shark. Bull sharks tend to be nasty. It's one of the ones that do bite people, okay? Florida had, out of the 47, I read this, out of the 47 shark bites last year, Florida had over half of them. We had like 24, which I found rather unsettling. But anyway, you got to be smart when you're around sharks. Bull sharks are aggressive in general, and they will go into fresh water. And when they come down here to pup, and when a whale has a baby, it calves, and when a shark has a baby, it pups. So I guess a baby shark's called a shark pup. But anyway, kind of weird. I don't know who got to name that either. I don't know why they just call it little shark or sharkette or something, but anyway. So these guys will actually come into close to Lake Okeechobee. They will come into rivers, and they've been found over 100 miles upstream in rivers, these bull sharks. So the bull sharks, though, will go up in the warm weather. They go up to around the Chesapeake Bay area, and this is actually a crown cow-nose ray that they're showing the migration, but it's the same migration as the shark. So there's a bunch of these that when I was trying to find a picture of the shark's migration, I found a bunch of other animals that do the same migration, which I found interesting. And let me just explain. Don't forget your thing, but let me just explain. When the water's cold, it can hold more oxygen and carbon dioxide and gases, and then that feeds the plants that are in the water, which means there's more food for the other animals that are in the water. So what they do is that they want to go where the water is colder in that it has a lot of nutrients in it, but it's warm weather when they do it, so they're not freezing to death. Does that make sense? So in the summertime, they go up here because the food's better. The food's better. And the tuna do it, and the sharks do it, and a bunch of these animals go up there and feed and then come back. And then the sharks come back down and they go basically to the same place, right around Sebastian Inlet, and in those places, the bull sharks do. Now, it said that they eat sandbar sharks. And at first I looked up sand sharks, and they're scary looking, but that's a sandbar shark. They're not very big, and they got a kind of a neat shape to them. But sandbar sharks, the book said, they only grow an inch a year, and they can live 50 years. And they tagged one off of the coast of Florida in 1969, and then, or 1968. 24 years later, they caught the same tagged shark. It was only 24 inches longer. I mean, these things don't grow very fast at all. And because the bull shark like to eat them, they go farther north. If you look at your picture on page 119, they go farther north to have their summer excursion up there. And then they come down and go all the way into the Gulf of Mexico to escape the bull sharks to have their pups. Okay? Yes, sir?
I read that the bull sharks, like, unlike most sharks, like if they bite you, you can hit their nose and they'll swim away, because the nose is sensitive. The bull shark, if you do that, it'll just hang on. It will just...
Okay, so the next trick is, if a shark ever bites you and he doesn't want to let you go, right, I think I've told you that. Poke him in the eye. Forget hitting him. Poke him in the eye. Okay? Or smack him in the gills. Or grab him in the gills. Whatever it takes for him to spit you out and go, you're too much work. Because you'll probably survive. So you want to do that. Okay? Although, as long as you know Jesus, I don't want you to give up, though. But, you know, at least if you die and you know Jesus, you're going home to be with Jesus, and that's a good thing. But we're all going to miss you, and you have kingdom work to do, so you need to stay here. So poke him in the eye, all right? All right. And then we get to Catherine. And this is Catherine the Great. This is a great white shark. That's why she was named Catherine. She was originally tagged in 2013, if I remember correctly. And therefore, she has been monitored. I want you to notice where Catherine has been. And she's right along the coast, isn't she? And she's been spotted in the Keys, and she's been spotted along our coast here. She comes in very close. Well, guess what? What did you know about her?
She was just pinged just last week. I can't remember where, but they said she was pinged.
Yeah, she has to come up actually to be pinged, apparently. And she comes up enough that they're able to find her and track her. Get this. There are at least 2 others that they're tracking, great whites, that are doing the same thing. And they apparently go up to the Chesapeake Bay area in the summertime. So there may be a lot more animals making that migration that we're unaware of, and they're just figuring it out. I'll give you an example. When I was a kid, I'm 58 years old, just give you an idea. When I was a kid, we knew salmon went back to where they were born to have their babies, and then they died. We didn't know sea turtles did. We didn't know penguins did. We didn't know all the stuff we know now because people have studied these things. Now we know penguins go back to where they were hatched to have their babies. And we know that sea turtles go back to the exact beach where they were hatched to lay their eggs. So there's a lot of animals that do this. Well, we're still learning all this stuff, aren't we? So now, I'm not happy about this, but we have great white sharks off the coast of Florida. Okay, and apparently they're migrating around. Part of the reason we notice the sharks more now, I don't know if you've ever read any books from the late 1800s on Florida. Florida was considered shark-infested waters. People wouldn't go in the water very far because of the sharks in Florida back then. So actually, we're kind of benefiting from the lack of sharks. Okay? Yes, ma'am.
A couple of weeks ago, my dad and brother went to the beach, and they didn't see the shark, but someone else saw the shark.
Mm-hmm.
And it was like a 5-foot shark. I was like, they took me to the beach like a couple days later. I was like, I am not going in the water.
Well, but sharks usually won't mess with you. And the thing is, beaches are like the perfect call the shark in for dinner because it's shallow water, people go in and they make lots of noise. Splash, splash, splash. So it's like it's like ringing a dinner bell, seriously. But in most cases, sharks won't bother you because we don't taste good. Like they'll tend to hit surfers because from the surfboard you look like a meal. Your hands and feet look like a meal to them. It looks like a seal, and sharks like seals. And so most sharks don't like the taste of people, so they spit you out. There are more crocodile attacks every year by like 6-fold than there are shark attacks globally. Okay? I'm more worried about the saltwater crocodiles, I'll be honest with you. I can see the shark coming, you know? That's why I don't like the water over there. Anyway, we got to keep going. That's a right whale. I told you the right whale, she comes down here to calve, and she calves along this area. It's a small area that they come to calve on, and they're spotted more here. There's only 600 left in the world, so that's why it's considered very endangered. Whereas there's like 10,000 humpbacks left, and they're still threatened. So the right whale, there's a much smaller amount. Then we get to the Sargasso Sea. Now, this is where the Sargasso Sea is, and that's what it looks like. It always makes you think of Reepicheep out there on his little coracle. If you've read the Chronicles of Narnia, I can just see him out there doing his thing, you know. But when you get to the Sargasso Sea, it looks like a meadow when you get in there, and it's a meadow of Sargasso seaweed. Okay, and the reason that it's there is because there are 4 currents that are constantly going like this, and it makes a giant eddy, if you'll excuse me saying so. And so it just causes all that seaweed to stay right in there. Now, what's really interesting about it, though, and the book pointed this out, is that, I'm going to go over here and find it for you. Hang on, because I want to get this right, because this is cool. The Sargasso Sea is it's more salty and warmer than the water that surrounds it. Let's see, here we go. It's saltier, and so it says here that it has been called the cleanest, purest, and biologically poorest water ever studied in the ocean, ever studied. It's warmer than the water around it, and it's lighter. If I said a lens to you, like a lens that came out of a magnifying glass, you know what I was talking about? The Sargasso Sea is a giant lens of water that's 3,000 feet deep and I don't know how many miles across, that literally floats on top of the ocean, and the whole thing rides 3 feet higher than the rest of the ocean around it. Is that weird or what? It's warmer, saltier, less nutrients because it's warmer. Remember I just said colder water has more nutrients in it, and so there's more life in it. This is warmer, saltier water that literally floats as a huge lens on top of the rest of the ocean, and the water doesn't intermingle. It goes under it and holds it up. How about that noise? okay? And the reason, that's why I wanted you to get a picture in your mind. It's bounded on all sides and below by cold, nutrient-rich water, which moves around it and under it, but does not migrate into it. And then it doesn't have as much rainfall as it has evaporation because it's fairly warm there, so it gets saltier and saltier. The reason that it's worth talking about is this is where the baby sea turtles go to grow up. They go there and they hang out and they grow up in the Sargasso seaweed. And you can kind of see the edge and how there's a change there. Also, the baby mahi go up there to grow up. And so there's other animals that are found that actually live under this seaweed. And those are your currents that show what it does. Now, it talked about the turtle migration, and this is a loggerhead turtle. There are 5 turtles once you turn, if you're not there, turn to page 123, 122 and 123. This is a loggerhead turtle. She will come into the beach where she was hatched to have her eggs, to lay her babies. She will dig a hole. She will drop numerous turtle eggs into it. She will bury it. She will try to cover it and to make it look like she wasn't there, to hide them. And then she will pull herself back into the water, all sandy and yucky. And the male won't come back in. From the time the male is hatched and goes in the water, he will not come back into the land at all. And the only time the female does is literally to lay the eggs, and that's the only time she'll come into land. So they really stay in the water. I don't know if you know this, but reptiles, they know this now. They didn't know this when I was younger, but now, depending on the temperature that the egg is incubated at, will make a male or a female. Yeah, which they didn't.
It's colder as a male.
Was it that way? I thought it was the other way, but one way or another, that it does make a difference. When the little sea turtles hatch, about 60 days later, when they get out of the hole, this was obviously dug up so people were monitoring it, they will head for the light. And that's why they're trying to black out the lights at the beach so the little turtles don't go the wrong way and head for a condo instead of the water. And the reason they head for the light is because they're heading for the moon that's shining off of the water, so they will head for the water.
They have lights, they just have to be yellow lights, I think?
Well, the point is you're supposed to black out so that it doesn't cause the turtles to go the wrong way during turtle season. Once the little turtles get in the water, they swim, the undertow guides them so that they swim out. And they know that because during storms where the and backwards, the turtles went the wrong way, okay? And so they move out, and then they go to the Sargasso Sea, and they feed at the Sargasso Sea, and they grow in the Sargasso Sea, and for a couple of years in some cases, and then they'll come back. Yes, sir?
I actually got to see some baby sea turtles hatch. It was like a few years ago. It was really cool.
It is. They're very cool.
This big.
Yeah, they're little bitty. And that's a danger for them because the sharks and everything know when they're hatching, and they'll just kind of wait out there like McDonald's, you know, they can just grab them. And so it's sad. Anyway, and actually in the Keys, there's some Sargasso seaweed that's growing from the bottom in certain places off of Isla Mirada, and certain times a year it's full of dinner plate sized sea turtles. They're about this big, and they're feeding out on the Sargasso seaweed that's right there. So it's fun to watch. There was one day that we had my brother out there coming back from penny camp. I think we saw 30 turtles just on the way back. And they were freaking out. They were like, we did that for them, you know, because we never see that many turtles. It was like God said, mwah, they kissed my brother, you know. And so anyway, so the sea turtles that are still left in Florida, there are 5 sea turtles that are still left in Florida. There are green sea turtles, and they're on the increase on my coast. There is the Kemp's Ridley. This is the most endangered sea turtle in the world. It's a smaller sea turtle. They're only about this big. That is a hawksbill. They are gorgeous, and therefore they're endangered because they used to kill them and use their shells for women's combs, decorative women's combs. And so they used to kill them for that. And that's why you never want to buy anything made from a real turtle, because if you do, somebody's going to go kill a turtle so they can keep selling it to you. So never buy anything from a whale or a turtle or a dolphin or anything like that. This is a leatherback. These leatherback, if you look on the book, the leatherback can get up to 1,500 pounds. That's almost a ton. These guys get big, and they're out there. I still see them, okay? So they're a really big sea turtle, and that just gives you a little scale. Can you imagine being that turtle and trying to get yourself up on the beach? It'd be rough. Honey, we're running out of time, so give me a minute. This is the loggerhead, but I noticed some of the loggerheads had these points on their shell, on the carapace, which I thought was interesting. Anyway, and this is how you would identify them. This gives you scale, whereas the leatherback is really big. The Kemp's Ridley is a smaller turtle, and the others are all smaller compared to the leatherback. But I don't know about you, but I was having trouble identifying which one's which, so I put that up there for us. Okay, and then that's your comparison of actual photographs of the 5 different turtles that you would see here in Florida. That's a different picture of a loggerhead, but notice it's still got the little spiny things on his back. So I just found that rather interesting. This was off the Space Coast right here. And this is a hybrid turtle between a green and a loggerhead turtle. Now that is interesting, and I want to tell you this, as a creationist, we know that things only reproduce after their kind, which means originally these turtles must have been the same kind, and now they're different species, but if they can interbreed, they must have been the same original kind. And they once found a cross between 2 baleen whales. It was a cross between a humpback and a gray whale, which means they had a baby. They had a mix, a hybrid. That means originally they were the same created kind. Okay, so pretty cool if you think about it. And then the last thing it mentioned was how the American eels actually go to the Sargasso Sea, and they lay their eggs there, and then they die, and then the little eels hatch. They look like a leaf, and then they'll eventually grow to look like a little eel, and then they come back in a lot of cases in Florida, they'll come back into the Gulf Coast, and then the females will go upstream and live upstream for 10 to 30 years before they'll head back to have their babies. And the males will live in the estuaries. They won't go inland, and they stay segregated until it's time for them to go back to the Sargasso Sea to have babies. And what's real interesting is there's European eels that do the same thing at the same time, and yet each of these, when they're born, they know which way to go. The American eels know to come back to America, and the European eels know to go back to Europe, and that's really weird as far as I'm concerned. So, Garrison, you had your hand up, sweetie?
Yeah, the hawkbill.
That's the American eel, just in case.
Hawkbill turtle.
Yes.
It eats like coral, and not really coral, like sponges and stuff.
Uh-huh.
But it's actually, it protects itself from sharks by swimming like sideways and using its shell as a shield.
Interesting.
And it bounces off. And that was actually what I think.
The spikes.
Yeah, the spikes were made
Spikes were
to
for?
protect it.
Yeah. I would imagine so. I like sea turtles, personally. And there's some issues with sea turtles because of the pollution, and they get tumors and stuff from some of the some of the stuff that we pour into the water is what they're thinking. We're not even sure. Man, you should see the pictures I've seen from Hawaii. They've got real issues out there with the tumors on the sea turtles.
Gumbo Limbo has them too.
Do they?
On the street here, they have.
Okay.
My son and I went a couple years ago. There was a couple of them with eye tumors. that
Okay.
we
Yeah, and it's sad because it's the chemicals we're pouring in the water that's doing it. So what are those chemicals doing to us? Then that's where chemistry becomes so important. A lot of people don't realize that, but our bodies are a big electrochemical factory. That's how God chose to design them. And so that's where if you choose to be a doctor or a vet or a pharmacist or anything like that, you're going to have to take a lot of chemistry. If you're going to be a nurse, you're going to have to take chemistry, but not a lot of it. Okay? Just so you know. Okay. External fertilization is where the male puts the egg outside, the female puts the egg outside and the male comes along and he fertilizes it outside of the female's body. That is usually in aquatic or marine environments. Internal fertilization does happen in aquatic environments, but more often than not, it's on the terrestrial is almost always going to be, I think terrestrial is always internal fertilization. I can't even think of an example of external. So the external or internal could possibly happen in an aquatic environment, but the external is definitely, did I get that right? The aquatic environment, you can have both. The terrestrial environment, you're only going to have internal. Okay. And then this actually shows you, this is an externally fertilized egg, this is a salmon egg. So they have a soft shell so that when the male puts the milt on it, which the milt contains the sperm, then it can actually absorb through the membrane on this egg. Whereas your internally fertilized eggs are like birds' eggs or reptiles' eggs where they're going to be harder or a harder shell. I say harder because a reptile's egg, its shell is kind of like the outside of a football. It's leathery. Okay, it's not crunchy. doesn't have the calcium carbonate in it to make it crunchy like a bird's egg. So if you ever find an egg and you kind of push on it, it feels leathery in your yard, it's like a lizard egg or a turtle egg, something like that. Let's hope it's not an alligator egg. If it is, run. Okay, all right, because mommy alligators protect baby alligators, so run. You'll know because alligator eggs will be in this big pile. They make a nest and it's a big pile. So don't go digging around in big piles of brush and stuff and finding eggs. If so, you're in trouble. Okay, then we got to those 3 words. We got to viviparous, oviparous, and ovoviviparous. And I told you that parus means to bear. So oviparous means what? Born from what? An egg. So if you're oviparous, that means you lay an egg and then that egg hatches and the baby comes out. That is an oviparous type of development. Hang on, I'm going to get the right word here. Yep, development. I got the right word. Wow, it's after lunch and I got the right word. Okay, viviparous. Viva means life. So what do we know about viviparous individuals? They are what born? Live born. They are live born, and you have to remember that viviparous are live born from a placenta. And so they have the attachment with mama that the placenta actually fed the baby, and that's why viviparous babies will have belly buttons, including the sharks that are viviparous will have belly buttons. That's kind of weird, but it's true, just so you know. And then you put the 2 words together and you get ovoviviparous, and that's when they're live born from an egg. And so it's an egg inside of mama, or in the case of seahorses, daddy. And then when they hatch, they come out of usually mama in a live form. So that would be the case with guppies and certain snakes, like rattlesnakes are ovoviviparous. I know that is like a gross picture, but that poor snake, look at her. Look at all those live babies she's having. Oh my goodness. And then there's daddy seahorse giving it up. Poor daddy seahorse. Anyway, see little baby saying, let me out of there. Okay, so they're totally exhausted by the time they get done. Okay, then that was where we ended last week. But so now we're on page 403. I know we went on and did our fish dissection, but we're going to start right where we are on page 403. Let's go from there. Then we get into class Agnatha. So now we are in subphylum Vertebrata. So we're looking at vertebrates. And within subphylum Vertebrata, we have class Agnatha. If you were going to classify Agnatha, it would be jawless fish. Oh, that sounds fun. So we're going to talk more about that in a minute. They're basically, I call them the vampires of the sea. And as far as I know, everything in this class are the vampires of the sea. So we'll talk more about that in a minute because it's such a lovely discussion. Anyway, it mentions the word anadromous. And everybody say anadromous. Anadromous. It is not pronounced the way the book says it is. Anadromous, really? It's anadromous. And the opposite is catadromous. And you know about that, anabolism, catabolism, right? You've done this before, haven't you? The opposites. Anadromous is actually like a salmon. You guys all know that a salmon is hatched in fresh water, that he goes down to the sea as a fish, and he lives in the sea for saltwater for his life. And if it's a Pacific salmon, then he only goes back home once, back home where he was born, to lay his eggs, to spawn, and lay its eggs, and then it dies. Now, Atlantic salmon do it more than once. They can breed, and lay eggs more than once. But Pacific salmon are the ones that once they go back, their muscles and everything turn to mush and they die afterwards, okay? But it's anadromous because it is an egg that starts in fresh water. He goes to the marine and lives his life, and then he comes back to lay his eggs here. That's anadromous. It's not in your book, catadromous. It's the opposite. Catadromous individuals start as an egg in salt water, and then they go to fresh water to live their lives, and then they go back to the salt water to lay their eggs. And the example I would give you, which is actually right there, is the American eel. And guess what? They live here in Florida. Oh, joy. And these eels will actually, on their way back out from freshwater lakes and ponds, they've actually been seen going across wet pastures to get to yeah, that freaks me out. To get to a creek or something so that they can head into the salt water. They will go back to the Sargasso Sea, which is up off it's in the Atlantic Ocean between the United States and Europe. There's the Sargasso Sea, that part of the the Atlantic Ocean, and they will go there and lay their eggs. And then their babies, which are called elvers, believe it or not, will make their way back to Florida, back up the streams into the fresh water, and live their lives for anywhere from 10 to 30 years before they do it again. Isn't that interesting? And what's also interesting is there are also European eels, and they all lay their eggs in the Sargasso Sea, and when they hatch, the European elvers go to Europe, and the American ones go to America. Nobody quite knows how they know which one they are. I think that is so cool. Anyway, so anadromous is the one you need to know, and the anadromous was the one that was like a salmon. Started in freshwater, goes out to saltwater, comes back to freshwater to breed, and frequently die. Then we get to the ones that are listed here, the agnatha ones, and it talked about the lamprey eel. These are jawless fish, and they also lack paired fins, and they also lack scales. You do not need to know that. It is not information in your book. It came out of the marine biology book. I just wanted you to know what these guys were. Also, what's in the, did I have that next? Yes. This shows the lamprey eel attached to the fish like it's in your book. So when they are larvae, I got you a picture. That's what they look like as larvae. Your book talks about the Ammocetes, and they actually hatch. They look like that for a couple years, and they produce strands of mucus. I was trying to find you a picture of that, and I couldn't. They produce strands of mucus, and then the mucus picks up the particles in the water, and that's what they use for food. And then they eventually turn into the lamprey. That's a picture of Ammocetes that they've pulled out of one place. And when they turn into the lamprey, they have these nasty teeth that they attach themselves to a fish, and with those teeth, they actually bite into the fish and cause it to bleed, and then they suck the blood until they suck all the blood out of the fish and it dies, and then they go do it again. Now you see why I call them the vampires of the sea, because that's what they do. You know what? They're not the grossest agnatha. We could just ditch agnatha. What do you think? Hagfish is another jawless fish that's in agnatha. The hagfish actually bores a hole into their prey and eats them from the inside out. Isn't that lovely? They secrete a slime layer to actually deter their predators from wanting to eat them, because if I saw that, I'd go, no, I don't think I'm going to eat you. And so that's the case here. So hagfish also, notice, jawless fish, no scales, no fins. So that's agnatha, and if we never have to go back to that again, it'll be fine. Okay, for my next trick, turn to page 404, 1312. Are there any lampreys that reproduce in marine environments? Now remember, lampreys are anadromous. So do they reproduce in marine environments? No. No, anadromous individuals don't. And I didn't mention that, remember, the lampreys started to, because they cut canals into the Great Lakes, these lampreys got into the Great Lakes and they started to eat up the fish population. And they tried to get rid of them, but they think maybe the pollution actually helped to get rid of them, because they would absorb the pollution when they're in the larval state, in the Ammocetes state. So anyway, 1313 says, a student says lampreys are parasites. How should the student's incorrect statement be modified to make it correct?
They are parasites in their adult stage.
Good. They're not in their larval stage, but they are in the adult stage. Very good. So we have to qualify. 1314, if a vertebrate relies on its sense of smell for survival, what brain lobes will most likely be larger as compared to those of other vertebrates? And Lily, you got to answer this one for me. Do you remember which word it was?
It was the one I was trying to think to remember.
Oh, okay. Somebody help her. Come on. Which one? Olfactory. Remember? Everybody say olfactory. Olfactory. Touch your nose and say olfactory. Okay, then go like this and go optic. Olfactory. Cerebrum. All right. Think, stupid. No, okay. I'm sorry. All right, then we get to chondrichthyes. That's why, don't you love that picture? Isn't that a fun picture? Chondrichthyes, remember, chondro means cartilage, and ichthyes means fish. And that's why if you have a Jesus fish on your car, it's an ichthus. That's actually what they're called. The Jesus fish is an ichthus. It's the Greek word for fish. And so Chondrichthyes means cartilaginous fish. Osteichthyes means bony fish. Well, we already looked at bony fish last week, so let's look at chondrichthyes, which are your cartilaginous fish. I just thought that was a cute picture. Anyway, so the first ones that are in here are sharks, and then the other ones that are in here are rays and skates. So these are the things that are in chondrichthyes. And now I want you to notice that there's all sorts of different types of sharks. And the thing that the book wants you to know, so go ahead and turn to the picture on page 406, please, is that they have nostrils, which are actually not called nostrils, they're called nares, N-A-R-E-S. And they're not nostrils like our nostrils. Our nostrils bring air in. A shark's nostrils, its nares, actually bring in chemicals so that it can use its olfactory part of the brain, which means what's it doing with the stuff that's coming in its nares? It's smelling it, exactly. Oh, we're getting somewhere here, right? Okay, Snoopy dance. All right, it has gills that are exposed. Notice that the gills are exposed in this picture. And I want you to hold your place on 406 and just flip the one page to 409. Are Osteichthyes gills exposed? No, what are they covered with? The operculum, right? So now flip back. You'll find that rays and sharks, chondrichthyes, have exposed gills as far as where it comes out. They don't have that operculum to cover that. They have a dorsal fin, which we actually saw the dorsal, the anterior dorsal and the posterior dorsal on the bony fish also. Caudal fin, that's the tail fin. You see that on the bony fish also. Then if we go underneath, you have the anal fin, you have the pelvic fins at the back, and then you have the pectoral fins up here. Now, I don't have a picture of it, but I want you guys know this. If you look at a shark, let's say we're looking, here, let's go back to that picture. When the shark is looking you dead on, he's very round, isn't he? His body shape is very round. Whereas look at the regular fish. Their body shape is very narrow, isn't it? It's very, very narrow comparatively. And actually, to make up, they usually have a bigger dorsal fin and the pectoral fins so that it can stabilize, okay? Whereas the shark is more rounded, it's shaped more like a torpedo. The other thing is, you couldn't see it on that other picture, the caudal fin of a fish is usually equal on top and bottom, whereas the caudal fin of a shark will usually be longer on the top and shorter on the bottom. And some people believe that that helps the shark to, motor up and down because it's got that difference. Unless, of course, it's a thresher shark and then it actually uses that huge caudal fin on the top to slap fish and knock them silly and then go back through and eat them, which is rather interesting if you think about it. But anyway. The shark, you tell me, what are the shark senses? First off, just name a sense. Okay, they have a really good sense of smell. What's another shark sense? Sight. They really can see things though. Just showing you that's the smallest shark in creation. That's the largest shark in creation. This is actually a plankton eater. So that's why you can swim along with it and not be afraid you're going to end up in there in trouble. Okay. But the whale shark is actually a plankton eater. And this little bitty shark is actually a shark and he's full grown. So they come in all sorts of shapes and sizes. The book talked about their scales. Shark scales are like little tiny teeth. And that's why historically people use them for sandpaper and the grips on swords and other things. It was very useful to people to use the shark skin for different tools, literally. Whereas regular fish scales, actually the one we looked at last week looked like that one where it had the little spikes on the back, so it would be a ctenoid scale. But the fish scales are different. Also fish scales, we had fish scales everywhere last week when you guys finished the dissection because they were going everywhere. The shark scales don't come off like that. They're like teeth. They're attached. Actually, his skin scales are attached better than his teeth. So, and that's a close-up of a micrograph of the shark's skin. I have some slides with it, but they're side views, and so they lose everything. They don't look that good at all. The shark's teeth will fall out. That is the one part of their body that is calcified and hard. And I've only got a piece of a tooth here. It's just a broken fossilized tooth. Okay, but they're They're hard, okay? And the shark's teeth, I'm going to go ahead and pass this around so you guys can see it. Please don't break my shark jaw. But the shark is constantly losing teeth, and so he's got spares like a conveyor belt where when he bites down and he loses a tooth, the one behind it just springs into its place. Don't you wish we had that? I don't know, the orthodontist would make a fortune on us, wouldn't he? But anyway, it's interesting how, and that's why you see so many shark's teeth on the beach and in the fossil record, because they fall out so easily. Okay, let's go back to the shark's senses. The shark has a good sense of, it says in the internet things that I've seen, hearing. It's actually talking about its sense of vibration. What part of the shark deals with vibration sensing? Yes, sir?
Lateral line?
Lateral line. It's the exact same thing that deals with sensors, vibration sensing in a fish, is the lateral line. Okay, then it has a good sense of smell. That's got to do with the pressure that it can sense. It actually has a reasonable sense of vision. And then it has the electric field sense. I thought it was so cool how they figured out they had an electrical field sense, because it kept picking off the flounders from underneath the sand without missing a lick. And that's because each of our bodies are actually electrochemical factories, like I told you. So we put off an electric field, and sharks have electric field sensors. That's the lateral line, okay? The electric field sensors are up here in his nose. These are his nares. And so these are called you don't have to know this, ampullae of Lorenzi, which are these little holes that do the electric field sensing. And so that's how they can find their prey once they're close to it. The other thing your book mentioned is that sharks will sometimes have remora. Let me go back to the electric field sense for just a minute. The book says that their electric field sense is so precise that it can locate a transistor battery radio that's like think AAA, okay, from more than 1,000 miles away. And I found that interesting because every time I looked up anything that talked about the shark senses, it put the electric field one to closer range than these others. So I'm not sure what the scoop is on that. Unless maybe it's older information in the book, I'm not sure. Let me say one other thing. Sharks like they like blood, the smell of blood. But they also, they also like the smell of urine and fecal material, which means you never want to be near a place in the water where there might be a sewage spill or something, because the sharks will come into that area. Okay? So you want to be careful about that. You never want to be in the water if you actually are bleeding, because they do smell it and it will bring them in, because they're set up to take out damaged fish. So if there's a damaged fish, they would come there and clean up the situation. So if there's sharks in the area, get out of the water. Don't try to be a hero. Get out of the water. If a shark ever does bite you, probably seen the movie Soul Surfer, so you probably know some of this, but if a shark ever bites you, don't panic. More people die from the loss of blood than from the shark bite, okay? If the shark grabs hold of you and doesn't want to let go, believe it or not, you punch them. You punch them in the eye, or you punch them in the gills. If you poke them in the eye or punch them in the gills, they will usually spit you out because they're not expecting a fight, okay? And I had a brother, when a shark came towards him once because he was spearfishing, my brother kicked it in the nose with his fin, and the shark backed off. It said, "What are you doing kicking me?" And it did back off of him. I have growled off barracudas personally, so you can use your head, okay? Use your head. And yes, and every time I would growl, the barracuda would back off and look at me. And as soon as I had to take a breath, the barracuda would come closer. Just kept growling the whole way back to the boat. Anyway, do what you have to. So, okay. So, if you ever do get shark bit, don't give up. Hit it. Poke it in the eye. Pop it in the gills. It'll probably spit you out. Be calm and get back and get help. You don't want to die from losing blood. And that's usually how people die from shark bites. Okay? But once again, if you know there's sharks in the water, get out of the water. If you know if they feed at night, so don't go in the water at night, Stick to the pool at night. Anyway, okay, that's my feelings. So sharks can do they can do internal fertilization. They do internal fertilization, but they can be viviparous or oviviparous. How about that noise? So they can actually have a baby attached to a placenta. This is a picture of remora. These remora actually attach themselves to the shark. This is the underside of the remora. The remora's head has the suction cup-like part so that it actually attaches itself. So this is its belly. And then it eats some of the food that the shark might lose, and so they tag along. That is a shark egg. You can see the baby shark developing in the shark egg. Okay, so this would be oviparous. That is a shark attached to its mama with a placenta. That is a viviparous shark. What a trip. Okay, I don't know about you, but that just woohoo freaked me out. Then we get to skates and rays. Now, a ray has a very thin tail. And a skate has a very fleshy tail comparatively, so it's an easy way to tell them apart. There are other things that they are different on, like rays actually are viviparous. They give live birth. Okay, and apparently with the placenta because they're viviparous. Whereas skates are oviparous, they actually lay an egg. But that's not something you can just look at it as it goes by and tell which one it is. So go with that tail thing, okay? That if it's got a very skinny tail, it's a ray, and if it's got a fleshier tail, so see it's still skinny, but it's fleshier compared to the stick-like tail of a ray, then it's a skate. Yes, sir?
Which one is viviparous again?
The ray is viviparous, and the skate is oviparous. It lays an egg. I just wanted to show you that rays can get pretty good size, okay? And actually, I've seen them bigger than that personally, and they jump, and they're beautiful to watch them when they jump. When I've seen manta rays that were probably 15 feet across jump out of the water, and you don't want to get hit by one. That could kill you. Anyway. Rays' teeth look very different than sharks' teeth because rays eat mollusks off the bottom most of the time. So they have crushing teeth, kind of like a cow's teeth. They're crushing teeth. And I want you to notice, see how their gills are here? That's the outflow. The inflow comes in an area on the top of their head called spiracles, and then it flows out through the bottom. And that's because if they're eating off of the bottom, if they were breathing off of the bottom, they'd be coughing up sand all the time, wouldn't they? So God designed them so that the water comes in the top and then it outflows through the bottom. But once again, notice there's no operculum. There's nothing to cover those gills. Those gills, it's just a flow through there. Okay, and notice its mouth. And you can feed rays. They're pretty neat. My mom likes to feed wild ones. My mom's a maniac. Anyway, that's a manta ray. And they tend to not be on the bottom quite so much. But you notice that's a ray, not a skate. Okay, then we get to osteichthyes, which we actually covered last week. So I'm going to go through this very quickly. These are your bony fish. The only part that has to be bony for it to be an osteichthyes is its skull and its backbone. That's it. Okay, the rest of it can be cartilaginous. Haven't you ever bitten into a piece of fish and gotten a rib bone and thought, oh, thank God it didn't break my tooth? That's because their rib bones actually are cartilage. So they're not as hard as thank God, right? As hard as the spine and the skull, which are the calcified portions. You went through and learned all this last week. Notice that the caudal fin is basically even on both sides. He's got a lateral line, what does a lateral line tell him about? Vibrations in the water. Very good. The operculum, remember he pulls the water through his mouth and then it goes out, being pumped out through the operculum to go over the gills. The gills, I hope you saw this last week, actually are almost like feathers where they have a solid portion and then the rakers, which are the portion that the water flows over. As the water flows over it, he opens his mouth and then he closes his mouth, which pushes the water through the operculum, and as the water passes through there over the gills, then it's able, the blood supply in the gills is able to pick up oxygen, dump carbon dioxide, and then proceed through the body, similar to ours. Atrium is the part of the heart that receives the blood. I did mention that to you last week. Ventricle is where it squeezes the blood back out. It's where it pumps the blood back out. And that's true of our heart too. We have 2 atria and we have 2 ventricles because we have a 4-chambered heart. Fish have a 2-chambered heart, so 1 atrium, 1 ventricle. Okay? And fish are ectothermic. Ectothermic. Oh, fish come in different shapes because of their design to live in different places. It talked about they have, well, we're going to get there in a second. They're ectothermic, which means they're cold-blooded. That means they have no internal means of regulating their body temperature. Okay, because you're going to learn endothermic soon, which means they can regulate their body temperature from inside. So fish cannot. If the water gets cold, most fish get cold. Okay? If the water gets warm, most fish get warm. Notice I said most. Billfish, tuna, stuff like that, they actually can be slightly warmer than the water temperature around them because their big muscle mass that they have, which is what we eat, and they go long distances, they can actually warm themselves up slightly from their muscle mass and using the energy. But they're still ectothermic in the fact that they aren't actually producing body heat to regulate internally. Okay? So just think, you know what? For ectothermic, just write cold-blooded. It talks about different examples of Osteichthyes, and it said that some of them have chromatophores. These animals that have chromatophores have all sorts of interesting colors. There are different ways that fish are actually designed to camouflage themselves. This is a means of either looking like a larger fish looking at them, or a larger fish might go for this thinking it's its head, and then this fish can escape. Okay, so it's used to protect it. Some fish, their colors are used to advertise them so that they, believe it or not, will scare other fish off because they're advertising so they think they might be poisonous or whatever. This is a type of coloration that it mimics another fish. And so because it looks like the other fish, this other fish might be aggressive, and this fish is protected because he looks like somebody that's really aggressive even though he's not. And then this is called counter shading, and you'll see this in whales too, where you have the dark over the top and the light over the bottom. This is because something underneath it looking up, this looks like the sky. It's white like the sky looks. And if you're above this thing looking down, then he looks like the ocean beneath him. So he disappears no matter if you're looking up or looking down. You see counter shading in penguins, orca, killer whales. You see this counter shading a lot. Marlin, okay, billfish, they're counter shaded also. All right. Anyway, and then that's advertising. It talked about the chromatophores. The chromatophores are where they get these pretty colors. Okay, and the chromatophores actually reflect the sunlight in such a way that you see all these beautiful colors, and they can either make them smaller or bigger, and in the process of making them smaller or bigger, they can change their colors. I've seen barracudas that were brown with stripes, and I'm bumping my husband going, those look like cudas, but they're brown with stripes, and cudas are supposed to be silver. And then they started to move and they turned silver, and I said, uh-oh. And so they have these chromatophores, and they can change the way they look so that they blend in with the reef, and it's just kind of freaky. Oh, octopus, they are so good at it that they look just like what they're passing, just like a cuttlefish does. As they pass it, they're looking like what they're passing. It's amazing. Anyway, it's got to do with these chromatophores. I wish we had more time. Have a blessed week.